Now that we've discovered the wireless devices, we can modify the default setup channels of the I/O if required. In this example, we have an outside air sensor that's also got light level. Now, what we can do is click actually onto the small spanner, the little grey icon here, or we can go into the channel setup. What we'll do is we look at the analog input channel. On here, we'll see that the first channel actually is a temperature sensor, currently reading a room temperature of 25.5. And here we have the second channel, which is showing again temperature in degrees centigrade. Well, it's actually not, it's actually a light level sensor, and we need to change that channel. So I'll simply click actually upon that, and I click on update, and I can actually write the value. By default, sort of standard values are actually sort of stored within the system. And the key one which you might want to change is this transmit hysteresis or hysteresis value. This means this is the value the temperature has to move by in order to transmit a value. So typically we would set in a value for here for our light level to actually to go up to 5. So we can change that value. It was highlighted in red because it wasn't correct. Again, simply click upon that. That'll write itself to the database. And here we're saying that for every 0.1 of a degree shift in movement, that will transmit a value back to the system. If you have temperature sensors, say on maybe boiler flow, boiler return temperatures, you might want to consider changing that value from transmitting every 0.1 of a degree to something a bit more sensible, maybe up to maybe 1 degree Celsius, something like that. Just closing this dialog box, some other things just to sort of show you whilst we're here. We can see here we have our device ID. And importantly, we have our transmit statistics. So TX is transmit, RX is receive packets, and the AC is acknowledgements, and NAX is no acknowledgements. From a wireless point of view, we really need to have this value as low as possible. So in this instance here, it's running great. So we've got transmits and receives, we've got acknowledgements from the system, and we've got no NAX. Also, what we have is we have a test communications facility where we can do a wireless test from our laptop. Simply clicking actually onto that, what that will do, it will send basically packets from the gateway to the actual sensor, and basically it looks to give you a simple sort of tick or fail or pass. Whilst that's running, we can sort of just talk about something else which is on there, which is to do with hopping. In this video, I'm not going to explain actually what the hopping, how to set this all up, but this is where you would actually take the wireless signal and you can bounce that, if you will, like through as a proxy or as a repeater through powered devices, such as the WEMS controllers, Controller 1 or Controller 4, or an MX cluster. And here what we could do is if I just click on there, just to sort of show you, you can see that we've only got one cluster in which we could actually bounce our wireless signal for our room sensor or outside sensor through that particular device. Okay, so closing that down, and our communications, so we've sent our packets and we've come back with a simple pass. I believe it's 89% and below will give you a red sort of dialog box to say that the communications aren't correct.